So today we're going to learn two additional shortcut theorems. We're going to learn the angle side angle and the angle side. And then we're going to mix all of them together and have to determine which one we have.
Doesn't pass up the wrong thing.
I don't know.
We probably hear it. I'm pretty sure you changed the shape.
If I turn it in somewhere.
Oh, I passed the flat.
I don't know, I only see answer keys. Okay, so the warm-up is kind of like those two homework questions that you guys thought, a couple people thought were confusing. In triangle JHK, which side is included between the given pair of angles? So between angle J and angle H, what side, using segment notation, would be included between those? If you need to draw a picture, you can, but you shouldn't have to. Which side is included between angle J and angle H? Maddie? JH, look at that. It's the same letters in the problem. Yeah. Or it could be HJ. Between H and K, what side would be included? Between angle H and angle K, Marquise? Segment HK. Yep. All right, switching triangles, NLM. Which angle is included between the two given sides? What angle would be included between LN and LM? Lauren? Angle L. Notice that they share those in common. And the next one? Included angle, no? Angle N. Okay. So today we're going to look at two more triangle congruents, which is our angle side angle and angle side. So in the past sections, we had to show either 6 parts were congruent, all the sides, all the pairs of angles, or yesterday we learned the two shortcuts, SSS and SAS. Today we'll learn 2 more. There's a third one, but we don't learn it until later, and that's hypotenuse leg. So the angle side angle is, of course, what it sounds like, 2 angles. It can't just be any side. See how the S is in between the A and the A? The side has to be the included side, meaning it has to be directly in between the 2 angles.
Excuse interruption. Dr. Tucker, would you please
Then the 2 triangles
report
are
to the conference room? Dr. Tucker, please report to the conference room in the main office.
And so you can look at the picture and see that we have an angle with 2 markings. We have a side with 1 marking, and we have another angle with 1 marking. And we can see that the side is included between the 2 angles. Okay. Let's see how I drew these. Down here, pay attention. The congruent side must be between. That's why it's called an included side. So not an example of not an included side would be side, angle, angle. Now some students will say, how do you know which way to go? Like clockwise or counterclockwise? Because like if you go this way, it's angle, angle, side. If you go this way, it's angle, side, angle, people think. But it's not, because you skipped over a side and an angle. So you want to go the way that they're closest together, and you're looking, does it have an included side? Is this side in between A and A? It's not. The included side would have to be in between them. So for example, side, oops. No, let's leave that one. And we'll put the angles here. Angle, side, angle. Has to be smack dab in the middle. Okay, now the other one is the angle side postulate. And this one is exactly what it sounds like. We'll have 2 angles. Should be plural. But this time it will be a non-included side. So it'll go angle, it'll skip over a side, it'll go to another angle, and then it'll have a side after that. Now technically the angle side, you can also use angle side angle. So look at the picture. First of all, let's see the angle side. So we have angle side. Down here, we have angle side. So that's angle side. Now the reason I'm telling you that you could also use angle side angle is if you know two angles are congruent to two angles, what else do we know? You know two angles of one triangle are congruent to two angles of the other. What else do we know about the third angles? Marquise? The third angles theorem would tell me that actually these are also congruent. So if you use the third angles theorem to mark that in the picture, then you also would have angle side angle as well. Now most students won't add in the third angles marking, and you're not required to because you can use AAS. But if you add it in, and remember on your quiz next week, markings are worth points. So if you mark that, that's going to help me justify what you chose as an answer. And this just says then the triangles are congruent. So for AAS, we want a non-included side. So this would be like angle side. Angle, skip over the side, angle, then a side. Now sometimes if you go the wrong way, like clockwise versus counterclockwise, you won't see it. Like this is angle and then it skips over a bunch of stuff. That's why you don't want to go that way. Because you're not having a side here or an angle there, so you want to go the other direction. So this will be angle side. If we saw an included side, that's when we'd have angle side angle. Included means it's ASA. These are both ways to prove triangle congruence. You just would have to name them correctly. And students will mix these up because they don't pay attention to the inclusion. Has to be smack dab in between two included angles. So again, today we have a bunch of just pictures where we're looking. We may add markings if the triangles are touching. Remember, we can use a shared side, reflexive property of congruence. We can use vertical angles theorem. We can use alternate interior, exterior, midpoints we might see, bisectors, all that good stuff. Same question as yesterday, are the triangles congruent? And this is what your quiz looks like, part of it. It'll say on your quiz, yes or no, you'll circle. If yes, then you complete the congruent statement. If you select no, you don't complete anything because they're not congruent. Okay? So, are the triangles congruent? Now we have three ways. We either have SSS, SAS, ASA, or AAS. You have one of four choices if you choose yes. We are not going to add in any markings. Well, that's not true. You don't have to add in any markings for this one. If you wanted to, though, you could use the third angles theorem. Okay, you don't have to, though, and I won't mark it on my paper, but if you want to, you can. We should see that we have an angle, one marking, and one marking, so put an A there. We see the sides match up, and we also see these angles match up. So I do have triangle congruence by angle, side angle. And then make sure you match up the corresponding parts correctly. So O, D, G was no markings, two markings, one marking. So we need no markings, two markings, one marking. So T, A, C. Technically triangle, T, A, C. The next one. Do we think these triangles are congruent? If so, by which postulate? If you need to, label the angles with an A, label the sides with an S. Maddie? Good. Angle, angle, side. The side is not included, so that would be angle, angle, side. And we have triangle ACB, which is one marking, no marking, two. So one, no, two. And this one was kind of in the same corresponding order. They didn't flip it around. Now, if you used third angles theorem, okay, which you can mark that this angle would be congruent to this angle, and if this were a proof, you would actually need to state that using third angles theorem, then I would accept angle side angle. On your quiz though, if you write angle side angle and you don't have those marked in your pictures, you will be marked wrong. Okay? So I will actually look at your picture, how you marked it. If you want to choose angle side angle, you have to use the third angles theorem. Next one. Always make sure you look at both triangles. The first one I see angle, angle, side, so it looks like AAS. But the second one has angle, side, angle. Since one is one postulate and one is the other postulate, not possible. Now the next one has some different markings on the triangles. We see one marking, I'll put an A there. I'll put the A with the one marking showing we have corresponding congruence. We see one marking for the side, S and S. And I see two markings, which is A and A. Then they have two markings and nothing over here. Okay, but that's kind of just extra icing on the cake. You don't necessarily need to know that, and it's not going to hurt you to know that either. We have angle, side, angle. We have angle, side, angle. That's enough to prove that the triangles are congruent. So angle, side, angle. Triangle BCA is congruent to triangle DFE. Why don't you guys try the next form? You will have some given information. You'll want to mark there based on your knowledge. A lot of you not marking anything, which is wrong. What should I be marking in the picture? Joseph? A shared side. You know PR is congruent to PR by the reflexive property. If you don't mark that, you're going to put not possible, which is wrong. So you have to make sure that you're thinking, can I add markings in? And the main part is when they touch, either at an angle or a side. That's when you're going to add markings in, or if there's given. So at this point now, let's label this angle, angle, side. So I have AAS, I have AAS. That is triangle congruence by angle, angle, side. Now if you used third angles theorem and you marked this as being congruent to this, then you could say angle, side, angle, as long as you have the justification in your picture. Okay. So triangle PQR was congruent to PSR by AAS. Now the next one says bisect. What does the word bisect? It says KXR, excuse me, bisects QT. Bisects. What's that mean? Haley? Good. Cuts it in half. Now I'm going to jot down cuts into two congruent parts instead of cuts in half, which is the same thing. So it's going to take segment QT and it's going to cut it in half. So here's QT. XR is slicing through it, meaning that TM is congruent to MQ. If you were writing a proof for this, you would say segment TM is congruent to segment MQ, statement. Definition of a segment bisector, reason. Okay? So that's based on the given, that's done. Doesn't say they bisect each other, just this is bisecting that. So that's the only markings. What other markings can I add in to this picture? Joseph? Vertical angles. Because we know vertical angles are congruent by the vertical angles theorem. And then at that point you might think, okay, I only have two things not congruent, but we do have parallel lines, right? If you have parallel lines, 9 times out of 10 it's alternate interior angles because these are going to be closed shapes. So let's see, this angle R is alternate interior angles with angle X. If you do it that way, it's angle, angle, side. If you were to mark also that T is congruent to Q, sorry this is so small, you can. Those are also alternate interior angles. In that respect, you would get angle, side, angle. So I'm going to put AAS or ASA. So it really depends on the markings that you would put in the picture. Joseph?
Would exit, like segment or have the two
No. If it said up here XR and QT bisect each other, then it would be. But right now, only this one is cutting that one in half. So, and RTM would be XQP. XQM, excuse me. Okay. Next one, again, I saw some of you not marking anything. What should I be marking? No? Shared side. Reflexive property. And if you don't mark anything else, this would be congruent by which postulate? Marquise? No, I only have one side. You said SAS, that would need two sides. AAS. AAS. Again, if you use the third angles theorem and you add in a marking here and here, then you can say ASA. But again, on your picture, I would want to see that. So TWU, VWU. Okay, this one always gets students. We do not have vertical angles. So first of all, I just want to tell you, these are not vertical angles right here. Remember, vertical angles are formed by intersecting lines. So yes, this intersects, but like these are like two different lines. So those are not vertical angles. We do have parallel lines, which again, let me draw some attention to those. I did know that's congruent to that. So I have one pair of angles. I have one pair of congruent sides. What other angles would have to be congruent? Steven?
A and B.
Yes, kind of. We wouldn't be able to call, well, we can call this one A. That's good. This one we can't actually call B because there's like multiple things, but I see what you mean. Why are those congruent? What type are those? Good, these are corresponding. So the corresponding angles postulate says those have to be congruent. And then at that point, if you don't mark third angles, you would have ASA and ASA. So this was by angle side angle. So AEB was congruent to BDC. Again, if you mark third angles, then you have the other option of AAS instead. Okay, a couple more. Again, some given. And some of you, if you're starting to struggle with this given, you might want to go back and look at your notes from earlier in the year. I can't remember what section, but we did a whole thing on like drawing bisectors. I think it was section 1.5 where we actually gave you a word, you had to draw a picture and mark it. So it says SQ bisects this angle. So this angle is being cut into two congruent angles. SQ is what's doing the cutting. It like has the knife. Remember I said dissecting a frog? Bisecting. So that's what's cutting through. It's cutting this angle, PSR, into two congruent angles in half. So if you were doing a proof, you would say angle PSQ is congruent to angle RSQ. Definition of a angle bisector. Angle bisector. Okay, so that's a marking based on my given. What other marking should I add in? Our favorite, fan favorite, the shared side. We're not seeing it. Do we see a shared side? Okay. Usually it's students' favorites. It's the first thing they mark down. It's the first thing they write in their proof. Okay. Now if you want to do third angles, you can, but I usually don't. So at this point I would have angle, angle, side, angle, angle, side. So this is congruent by AAS. Triangle QSP, QSR. T is the midpoint of PR. T is the midpoint of PR. What's the definition of a midpoint? Definition of a midpoint is that it what? Marquise?
It's a segment of two congruent angles.
Good. It's a point that divides the segment into two congruent segments. So PR, T is the middle of PR, so we would mark PT congruent to TR. If this were a proof, definition of a midpoint. T is the midpoint of PR. Okay? That's all I can do with that. I cannot mark those congruent to that because it doesn't say T is the midpoint of QS. We don't know that. But we do see what else in the picture? Gail? Vertical angles, which we know by the vertical angles theorem, those are congruent. So now we have what type of triangle congruence? Okay? Got angle, angle, side. Not angle, side angle, because the side is not included. If you use third angles theorem, though, you can have angle side. So PQT, RST. All right, we're going to skip over the next two so we can get to the couple others that are on here. So what other information do you need to prove the following triangle is congruent by the reason shown? So what else do I need to know to prove angle, angle, side? Now before you start writing stuff down, you do want to mark anything you know. So we would know in this picture that vertical angles are congruent without being told. We can conclude that on our own. So what other side or angle would I have to know is congruent so that it would be angle, angle, side? Brett?
That D is congruent to angle B.
Yes. D is congruent to B. That way I would have angle, angle, side, angle, angle, side. In this one we want to prove angle, side, angle. What other piece of information would I need to know? Joy? Good. I would need to know that these two segments were congruent in order to prove ASA. And on the back we have a little proof to take a look at. And we've really been doing proofs the whole time, we just haven't been writing them out, but I've been stating it out loud. So we do have some given. It's already marked. What else can I conclude from the picture? Kaylin? Vertical angles. Can I call this angle Q? No. So in the proof, I have to either say PQT or TQP. Okay, remember the middle letter is the vertex. So we write it down. Angle PQT is congruent to angle, and you can say RQS or SQR. The angle, the order doesn't matter as long as Q's in the middle. What's the reason for that? What? Good. Vertical angles theorem. It's not the definition of vertical angles. The definition of vertical angles would just be that they are vertical angles. They're formed by intersecting lines. And then what type of triangle congruence do I have? Do I have SAS, SSS, ASA, or AAS? Marquise? ASA, ASA. Good. Now, if you're doing a proof and you want to use the third angles theorem, you could. You'd have to add an additional line to the proof. Take angle T is congruent to angle R, third angles theorem, and then you could use AAS instead. The proof statement just gets rewritten, this whole thing, down here. Tomorrow what we're going to do is we're going to work on harder proofs that aren't just 3 lines long. So it'll be kind of reinforcing everything we've already done, but just adding in the proof piece to it. So tonight you only have one short proof, and then most of them are just looking and classifying. Now, some students every year will struggle significantly with this unit. Others will think it's the easiest thing they've ever done in their lives. It's easy for them to see AAS, ASA. Some students struggle to know which way to go and how to name the letters. And if you're one of those people, please come in homeroom. I have a bunch of extra practice worksheets that we're not doing in class that I can go over and we can do together. Just looking at a picture and saying yes or no, what type. Because before we get to proofs, it's important to be able to identify them.